So we're gonna generate some random data that follows uniform distribution, normal distribution, and also exponential distribution. So here we go. The first thing we need to do is just to set some object. We want to generate random data that follows uniform distribution, and this is what we do. You can just say maybe random uni. Random uniform distribution. So then we can assign it something of this kind. So here inside we need to put some arguments to this function arrayUnif, meaning random data that follows uniform distribution. So we gonna write the total number of values that we need. We can just say even 1 million or 1 million, and from there we can just enter the minimum value that we need. The minimum value we can just say let it be even 20, and the maximum let it be 100. So that is the case. We are done with generating random data that follows uniform distribution. So right there we can just call the object random. Sorry. So we have random. This is our object now. So in case we run everything here, we're gonna have the data right here. So the values are 1,000. If you want to see how many they are, you can just enter length. You can just say length, and inside you can just say random. Random, this one. This is our object that we created right there. So in case you run that, you'll just know that it is 1,000. So 1 million, I'm sorry, is 1 million. So in case you want to know the summary, so you're gonna have everything, the six values or 6 summaries. You can just have something of this kind. So the summary of this data that we are having right there, it's gonna give us the minimum, the first quartile. You can see it in the console. So we have the minimum value, the first quartile, the median, the mean, the third quartile. We have the maximum value, and that is how we have generated random data that follows uniform distribution. In case you want a box plot, you want a histogram, here we go. We can just write histogram. So that is the function, and inside we can enter our object random uniform distribution. So that random data, that sample that we are having right there, we can just run this function right here together with this argument, and so if we run that, we're gonna have a histogram, and you can see it's following is very uniform. You can easily notice that. In case we want a box plot, we can just say so box plot. That is the case. So we enter again our object. We enter our object. So yep, that is our object. So in case we run that, we are gonna have our box plot. So if you want your box plot to look a bit to look horizontal, so you can just say comma in that argument. You can just edit the argument and say that data, then you say horizontal equals to true. So you're done. In case you run that, we're gonna have a horizontal box plot. You can see it has no outliers, and it's very it's appearing that our mean is at midpoint, our median is at mid. This one simply shows that mean and median are equal. Mean and the median are equal almost. So you can look at our summary and see that we are having the median that is 59.95 and the mean is 59.97. So they are approximately the same. So thank you for watching. Let me see you in the next video. We shall be presenting data for normal distribution and exponential distribution. Thank you very much.